Hello guys, Winston here. While I was in Cleveland, I had the privilege of touring the shop of Woodpecker Tools. Chances are you've seen the brand around social media in the past year or two and know them to produce unique but high-precision tools in a familiar red color palette. But I personally knew very little about the brand, so when Patrick offered to hook me up with a tour, I was 100% on board. Now, because this is an active manufacturing environment and I wasn't about to wire up my guides with lav mics, the audio from my footage is pretty unusable. Plus, I can't speak shop lingo as well as John Saunders, so you'd honestly be pretty bored. My live interview technique needs work, but I do want to show you what sort of operation Woodpecker runs and some of the cool factoids I learned along the way. So sit back, grab a drink, and listen to the calm, soothing sound of my voice as I record this voiceover in a cramped Airbnb, ignoring the Sphinx cat that keeps pawing at my door looking for head scratches. Woodpeckers runs out of an unassuming building in Strongsville, Ohio, but inside is a super high-tech operation that turns out precision tools that far exceed what most people look for in woodworking tools. Engineering and manufacturing happens under one roof, and I was surprised to learn that all of their CAM programming is manual. They design in SolidWorks, but they don't use any CAM packages to export their G-code. My understanding is that they don't even use the conversational interface on their Haas machines. It's literally all by hand. The reasoning behind this is so that the machine operators can make quick fixes immediately in the G-code, and this works because all of their parts are 2D. I spent a few minutes observing the production of some of their clamping squares, and I was curious about the order of machining that they used. They have a pallet system, which on this machine is set up for two operations. The first stop uses side clamps to hold a large bar of aluminum, which goes in like this and comes out like this. It's faced and spot drilled, holes for mounting are also fully drilled out. Then the stock gets transferred to position 2, where the holes in the clamps are fully formed. Afterward, the clamping squares are fully cut out. I'm personally a little curious as to why it takes 3 operations. My untrained machinist brain thinks that ops 1 and 2 could be combined if you just kept them in the side clamps, but maybe the extra rigidity of bolting the plate down makes it worthwhile. None of the through holes that are drilled in Op 1 end up in a finished product, they're purely for work holding. Anyway, I digress. I don't mean to analyze someone else's manufacturing process, that's just where my mind wandered off to. Moving on, I got to check out their cluster of turning centers. They have a bunch of CNC lathes with bar feeders, and they do run lights out. They also have lasers and automatic saws, passivation for steel parts, water jet foam cutting, finishing, and so much more. Woodpeckers has invested in some serious production capabilities. They have a bunch of lasers for marking parts. The anodizing of aluminum parts is one of the few things they don't do in-house. And also, their extrusions are made by someone else in Ohio. They save all of their fixtures for different products, so on the off chance one of their one-time tool lines is revived, they can put those setups back on the machines. Assuming, of course, they haven't made any part or process improvements since then. They've been known to iterate on products before. QA is one area I want to touch on. They sample a percentage of their parts to validate the overall process, and I thought it was pretty cool how they did it. They use non-contact optical measurement systems to check the thickness, straightness, and roundness of programmed features. The edge detection relies on a silhouette from light passed underneath the part, so the measurement fixture needs strategically placed cutouts to let light through. A lot of thought has to go into something like this, more so than just using a traditional contact-based coordinate measurement machine. And of course, some parts just need good old-fashioned checking. Here's one of Woodpecker's squares on a granite table and a 3/1000 shim. This thing is dead perpendicular and straight. Woodpeckers also has a little studio for taking some glamour shots and basic filming, as well as an addition they're looking to expand into. All in all, it's a really sweet operation and something Ohio ought to be proud of. I don't mean to sound like I'm trying to flatter woodpeckers, but as an aspiring machinist and a new woodworker who's only owned budget tools, it's refreshing to see such a high-tech approach and attention to details in the development of quality tools. I hope you found this glimpse into Woodpecker tools interesting, because I definitely did. I want to thank you all very much for watching, and I'll see you soon with more CNC-related content from the road trip.